So welcome to this class. In this session, we are going to introduce the concept of complex integration. We're going to give the definition of complex integration and then define a few terms related to complex integration. And then the next session, we'll give examples on how to carry out complex integration. So complex integration assumes that you have already known how to carry out integration of real valued functions. So start by the connection between the complex integration and real valued function integration. So connection between complex integration, complex line integrals, and real valued functions are real line integrals. Or simply connection between the complex integration and real valued function integration. So let's, if f of z is given by u of x, y plus I v of xi, xy, or simply this is the same thing as saying f of z equals to u plus iv, where we know that u is a function of x, y, and also v is a function of xy. Then the complex integral given by integral a to b f of z dz, or simply denoting it as integral along c f of z dz, can be expressed in terms of real valued functions or real line integral as, so we write the integral along c, the curve c, of f of z dz is given by the integral along c, f of z is given by u plus iv, that's from our definition, and then dz, remember z is given by x plus iy, so which means dz is the same as dx plus I dy. So where this dz we replace by dx plus I dy. Now we can simplify this, saying that the integral along C of f of z dz is equal to the integral along C. So u times dx, you get u dx. U times I dy will be I u dy. IV times dx will be plus I v dx. IV times I dy. I times I is -1, so I have negative. V times dy, v dy. Now collecting terms, real parts and real parts together and then imaginary parts together, we have integral along C of f of z dz will be given by the integral along C. So we have u dx minus v dy. So these are the real parts, plus the imaginary parts. We have I u dy plus v dx. So which we can write it as the integral along C of f of z dz is given by integral along C of u dx minus v dy plus, and then I put I outside the integral sign, along C of v dx plus u dy. So this is the complex line integral. That you are trying to relate to the line integral for real valued functions. So that's what we have. So this is sometimes taken to be the definition of complex line integral. Now let's set up some properties of complex integration. Properties. Of complex integration. Properties of complex integration. So some of the properties are actually similar to integration of real valued functions. So if f of z and g of z are integrable, along C, then the first property, integral along C of the sum of these two functions, f of z plus g of z dz, is the same as the integral along C of f of z dz plus integral along C of g of z dz. It's the same property for really valued functions, that the integral of sum of two functions is the same as sum of the integrals of respective functions. Number two, integral along C, I have a constant multiplied by a function f of z dz, is the same as taking the constant out and then integrating the function with respect to z. So where A is a constant. A property number 3, integral from A to B of f of z dz is the same as negative integral from B to A of the same function with respect to z. That when you interchange the limits, then we introduce the negative sign. Number 4, the integral from A to B of f of z dz is equal to the integral from A to m of f of z dz plus integral from m to b f of z dz, where points A, m, and b are on C, or this path along the path where the integration is taking place. Number 5, magnitude of the integral along C of f of z dz is less than or equals to product of two numbers m and l, where the absolute value of f of z is less than or equals to this number m. So m is an upper bound, or it's called the upper bound of the absolute value of the function f of z on C, the path of integration, and L is the length of C. So that's what we have. And then you can say number 6, which is just an extension of the property number 3. If we have integral T u v of f of z dz, the same as negative integral of v u t of the same function f of z dz, where t, u, and v are successive points on the curve. So this simply means changing the order, then introduces the negative sign in the integration. And then number 7, integral C1 plus C2 of f of z dz equal to the integral along C1 of f of z dz plus integral along C2 f of z dz, where C1, C, C1 and C2 are curves from A to B, A to M, and M to B respectively. Then C is the same as C1 plus C2. So when we have these points A, and then the point B, and we have M, so simply integrate from A to M, then from M to B. So this is where we have C1, and this way we have C2, this region. A to M, then plus M to B gives you the integral from A to B. And then from A to B is the part which represents the whole curve C. So those are the properties of complex integration. So thank you.